So, okay, guys, so welcome to the demo of Cloud Performance Engineering and DevOps, everyone. Okay, I do see people are joining. Okay, so welcome, guys. I hope I'm audible and you guys can see my screen. Do let me know if you have any issues from my end. I'll try to correct that. Okay, so I'm assuming like all the people in this forum who have joined are from performance testing and engineering background. Is there anyone else who is not into this domain, performance testing or engineering, or in some other field? IT domain. I'm assuming that. Okay, so I think the silence speaks. Like everyone is. I'm assuming that everyone from performance testing and engineering background. Okay, guys. Okay, yeah. Someone wanted to speak.
I'm not from an IT background, sir.
Okay, you are not from IT background. Okay, so.
But I'm an engineer. I have completed my BA and MTech.
Okay, Rajendra. Good to know. So
Thank you, sir.
you're looking for a job basically, right?
No, I'm working as a lecturer in one of the college here in Karnataka.
Okay.
So I was planning to switch to change my profession. So I've just thought of attend today's demo and look at what exactly it is.
Perfect. I hope you will learn something. Yeah, sure. Thank you.
Thank
Okay,
you, sir.
sure. So before I get started, so this is something about me. This is Roshan. I'm having around 14 years of experience in IT. Mostly worked into performance engineering, Java and Python development. Certified architect associate cloud professional in various cloud service providers like with AWS, Azure, and GCP. Been involved into automation using Java, Python, Terraform, Ansible, PL SQL, shell scripting, Selenium as well. I'm currently working as a principal SRE, site reliability engineer, performance engineering and DevOps professional. Okay, so before I get started, so this will be the agenda for our discussion. We'll start with a question. We'll try to understand what do you see about this question. We'll understand the software development and deployment evolution, and then we'll lay out the course syllabus and we'll set the expectations for you guys. And we'll go ahead with Q&A, and we'll also cover what will I learn by the end of this course. Okay, so let me get started. Okay, so how many of you agree that all the performance engineers or testers are expected to know this based on the current market trend that we are talking about cloud, containers, microservices, DevOps. So how many of you would agree that all the performance engineers, testers are expected to know these technologies? You can unmute to speak, perfectly fine. You can use the chat option to mark your comment. Someone want to speak? Okay, Rajendra says no idea.
Yeah.
Right, Trisha? Yeah, you have.
I agree that we have to know all these concepts as part of our day-to-day life as performance engineers.
Right, exactly. So this is where this course is all about, and we'll understand where these technologies come into picture and place in the IT world. Okay, in my next slide. So I do see like Madhuri do understand that and agree that yes, we do need to know. And there are some people who have no idea. Rajendra mentioned that he is not having any idea. So I think Rajendra, you are from performance testing background. Okay, as you mentioned, no, I think you just mentioned, right? So your lecture.
Yes, sir.
Right?
Yes, sir.
Okay, that's fine. Okay, yeah, that's why I think you. Okay, so this is where. So let's talk about this slide. This is where the software development and deployment evolution has happened, right? This is how. So if you look at the things way 1980s, how things were done, and look at the things how we are doing things now. This defines that yes, we do need to do these technologies as per the current market trend. I request everyone to be on mute if you're not speaking. Thank you. So look at this. So way back in 1980, right? So as part of the development process, we started with waterfall, right? When software development started, and currently we are working into DevOps. and in between there is agile. We're still into agile. There's not much difference between agile and DevOps. The only part is that I'm going to automate everything as part of agile, and then it comes DevOps part. Okay, so this is where the development process has started, and I would say evolved over the period of time. Right. Earlier we were developing mostly monolith application. When I say monolithic application, basically all my business logic resides in one application server layer. Let's say I have a three-tier application. The front layer, let's say this is the web server, this is the app server, this is the database server. I'm talking about the business layer, the application layer. Here, in the case of monolith application, I have every code resides in one application server. But we understand now the demerits of such a deployment, and now we are developing into microservices. This is where we have split we are splitting these different modules, and we are creating microservices now because we understand the benefit it brings on the table, right? It gives us robustness of the application and easy to manage, right? A lot of deployment can happen if you're developing microservices, which are not in the case of a big application, tightly coupled application. Here, the things are loosely coupled, right? We are calling REST API calls. I'm not calling the functions from one module to another function. I've exposed the REST endpoint, and I'm calling those RESTful endpoint if I need to get some information from some other module. So this is where the development is going on. And I hope you guys must be testing mostly API testing now using various tools, Jmeter or LoadRunner or Gatling, right? You must be using that API testing now more than what you used to do earlier. We used to mostly work on the web-based application, but here now we are mostly testing the API-based applications. Earlier, we were using, if we have to deploy our server, we used to use a very big physical server, big, like understand the cost, like 100 of vCPUs, 100 GB RAM, and we used to install a tiny little application there. We were wasting a lot of resources back then. Then the virtualization came into picture. I was able to create VMs. I did not install my applications on the physical server. I started to deploy my application on the VMs now, and I was able to efficiently utilize the resource when I created VMs. I hope everyone would agree that what was the main intention, what is the main thing that you see between this physical server deployment and virtual server? What is the thing we are achieving here, guys? Can anyone tell me? We are all from performance background. What are we achieving here? Can anyone tell me? Resource utilization. We don't want to, right? I hope everyone agrees, right? Because we were wasting a lot of resource here on the physical server, but now we are creating VMs. We virtualized. We install something called hypervisor, something called virtualization software. A lot of virtualization software exists in the market. There are some from VMware or some from Oracle, from different vendors. We have virtualization software. We install virtualization software on the physical server, and then we could create VMs, multiple VMs. And now in each of the VM I can create one. I can install one application. Let's say in one VM I can have my web server. In another VM, I can have my app server. In another VM, I can have my database server. Right? That's how I can do it. So earlier, it was not the case, right? I used to install one tiny little application, few KBs into big physical server because we did not know that virtualization something exists. Right? It came later, but now we are in the phase of containerization, where in one VM in one VM, I am able to create multiple containers. The goal is same, efficient utilization of the resource. That is the goal is same. But now, let's say for three-tier application, I needed three VMs. Let's say that I needed three VMs for three-tier application. Now, in one VM itself, I can create three containers, and I can have a three-tier application. Wow. So what I'm achieving here, I'm achieving the resource utilization again. When one VM is fully utilized, then only I'm going ahead with the another VM, right? That's what I'm achieving. So I can create three containers in one VM itself. Like one container can be my app server, another container could be my web server, another container could be my database server. Containers are like processes in a VM, right? This process is called containerization. And when we have a lot of containers, right, we need something called container orchestration engine like Kubernetes, right? You guys must be heard of this term, container orchestration engine, where we deal with pods, containers, right? So that's where this containers is, right? Lie. And then if back then, if you have some business idea, right? Let's say you want to deploy some application, you had no other option but to set up your own data center. It was a very costly affair. Setting up a data center is a very costly affair. Not everyone can afford that, right? It's a very costly affair. You have to do land acquisition, build infrastructure, purchase all the servers, storage, networking, cooling mechanism, everything, security. It's a very costly affair setting up a data center, right? Then back around 2000, some hosted provider came, and people we were able to host their application in some other data center, right? But now we have cloud, likes of AWS, Azure, and GCP, Oracle, IBM, Alibaba, right? There are so many cloud service providers. We don't have to set up my data center. If I need a server, I can go and rent it, right? And I can deploy my application. I can run my workload. I don't need to invest so much amount, right? And I can pay monthly bill, right? So this is where I talked about. So not just performance testers or engineers, right? Basically, all these things, DevOps, microservices, containers, and cloud, uh, everyone should know. That is what the fact of the situation as per the current market trend. And if you are not in this zone learning these things, obviously you are behind. There is no doubt about that. Like I have been talking about this from past 2 years, 3 years, right? Still, so it's a high time for everyone to learn. And if you're already working on this, perfectly fine. You are as per the trend, what's going on in the market, right? That's what I can say. So yeah, that's all about. Do we have any questions on this slide? Anyone? Follow up questions? Any questions, clarifications I can make?
Hi, Roshan.
Yeah, hi, Madhuri. Yeah.
Hi. I did not understand that container concept.
Okay, see containers. Okay, so currently the application which you are working on is mostly on the VM, right? Directly, you have a server, application server, web server, or database server directly
Yes.
installed on the VM, right? Right.
Yes.
But now what we have, right? We have see Google. See, I hope you would agree that Google handles load, manages load better. No one handles load or manages load better than Google, right? I hope you agree that because
Yes.
we
Yes.
hit so many times, everyone hits, right? And Google were using Kubernetes from last 15 years, and that's how Google were able to manage and scale to that many concurrent users because of this container concept and because of the Kubernetes container orchestration engine. So the idea of this containers is, let's say in one VM, I'll just try to brief about that, and maybe during the course I'll speak a lot. See, let's say this is the VM, right? And let's say you have a three-tier application. You have let's say you have three VMs going on. So one you have installed app server, one database server, one app server. Let's say that. Now, when I talk about the containers, right? So you basically on this VM you have an operating system, correct? Let's say
Yes.
Linux operating system. On top of this VM, you will install something called container engine, like Docker. Docker is a container engine. There are other containers engine as well in the market, like Rocket, Docker. We have Container D. All right. We have Podman. We have different containers engine. Okay. I request you to be on mute. I'm getting a background noise. Yeah, thank you. Yeah, if you have any follow-up question, you can unmute and speak. Yeah. Okay. So let's say this is the VM, and I will install something called container engine. Okay. See, container engine like Docker. And once I install the container, what it does, it virtualizes the host operating system. See, there are difference between this virtualization. In the virtualization, what happened? Let me do one thing. I'm gonna put a MS Paint. Okay, I'll do one thing. Okay, so let's say I have this physical server. Okay, let's say that this physical server I had. Uh, then I installed something called virtualization software to get started. I'm talking about the virtualization now. I installed something called virtualization here. Virtualization software like VMware software, like or some other software I installed. Okay, let's say that I installed some virtualization software. This orange is the virtualization software I installed. Once I install this, I can create multiple containers from it. Okay. After that only, I was able to create multiple VMs. Sorry, multiple VMs. This is the physical server. I was able to create multiple VMs, and now you are working on these VMs, right? Separately, these three VMs. And now what I'm talking about, I installed something called virtualization software. This is what I installed, and this process is called virtualization. Okay. Now let's take one VM. Okay. And what I'm going to do in one VM, pay good attention. So let's say I have now one VM. I am going to install something called container engine in this VM. Okay. Let's say I install container engine. And then I can create multiple containers. That's how I do it. There's a process to of how do I create containers and how do we host microservices on the containers. That will take some time for you to understand, but just know that now let's say I needed three VMs for to run my three data application. Let's say that I needed one VM for my app server, one VM for web server, one VM for database server. Now I can create three containers here. When I install container engine here, let's say the Docker as the container engine. I install container engine like Docker. I can create containers in this VM, right? There's a command to do. I'll talk about that, and then I can create multiple containers here. One container, second container, third container. So here I needed three VMs, but now I can manage these three applications in one VM itself by three containers, right? And the idea is that the virtualization software virtualizes the hardware. Okay, it virtualizes the hardware, but the container engine virtualizes the host operating system. Let me show you one diagram if I have it. Okay, let me, since you asked this question, let me just take a minute. I just hold on, guys. I just need to take one slide. Okay, let me talk about it. So this is the course syllabus PPTs I share with everyone. I'll talk about the architecture of a virtualization and how containerization are different, right? I'm gonna directly take you to that particular slide. Okay, pay good attention here. See, uh, so this is the virtualization, and this is how I'm creating the VMs. Okay, I have a physical server. I install something called virtualization software. Hypervisor could be one of the virtualization software, and then I can create VMs. This is VM1, this is VM2, and this is VM3. All my VMs has a separate operating system, right? But now I have taken one VM here. This is my one VM on my right side, which I'm showing you. That's my one VM. This is my one VM. Okay. In that VM, I'm going to install something called container engine, Docker. And then I can create containers in it. The idea is that the hypervisor virtualizes the hardware. Okay. But the container engine virtualizes the host operating system. And that is why these containers do not need separate operating system, though they are a separate application. This is a web server. This is the app server. This is a database server. But these containers do not require a separate operating system like in the case of VMs. That's the best part. And that is how this is a technology, containerization. And this is why this Kubernetes and all those pods which you have heard about, they are based upon, right? So that's about a brief. I hope you got some fair idea about this, Madhuri. We'll talk
Mm,
we'll talk in
yes,
detail.
yes.
How do we create it? What command we type? How do we create it? How do we host it? We'll talk about that. But just know that we can
Okay.
create a containers in one VM, multiple containers.
Okay.
Okay, sure.
Uh,
Yeah. Someone else had any question?
Roshan, can I have a word here?
Yeah, go ahead.
Yeah. So you mean to say that in order to have a virtual machine separately for web, for your application and data center, you can create single server, and in that you can keep all these web server and app server, data server. That is what is all about container, right?
Containers. I can have one container for web server, another container for app server, another container for database server in one VM itself.
Okay. Fine. Yes, thank you.
Roshan,
Yeah.
the Kubernetes and all, right? These are all come as a container based software or
So
Kubernetes and all.
see, to create containers, we need container engine. Okay. To create containers, we need container engine. This Docker is one of the container engine. But to manage, let's say you have multiple containers, right? You want to auto scale based on the load, you want to auto scale, you want to auto deploy, you want to auto schedule, you want everything automatically done, right? So you need an orchestration engine. That orchestration engine is called Kubernetes. Popular container orchestration engine is Kubernetes. It is from Google. Google are using this from last 15 years, and this is how they're managing their workload. And now it is
That means, see, the communication between one container to another container or any other auto scale is required, and
yes.
to maintain all these.
When I say orchestration, communication between the containers is possible without using Kubernetes also. Okay. When I have Docker installed, I have multiple containers anyway. The communication will happen between these containers using the overlay network. That is the bridge network that we have within the Docker. But when I say orchestration means auto scaling, auto scheduling, load balancing, right? A lot of capabilities, right? Orchestration means that, and that orchestration is done by Kubernetes. I'll come to this.
Okay.
This is the course. Okay, that's about this course. Okay, let me talk about this course. Then you will have your questions. Okay, let me talk about this course. Okay, so let me go back to where I was discussing. Okay, so this is the first slide, right? So let's talk about the course now. Okay, what this course is all about, which I have come up with. I understand this where we are in the transition phase, and as a performance testers, engineers, or anyone in the industry, we should know all these technologies, right? So let's introduce the course, what we have. So this course which I'm coming up is we are going to target these things: AWS on the cloud front. So let's just remember these four things which we have discussed, right? The four things which you have discussed: DevOps, microservices, containers, and cloud. We are going to cover everything here. And that's why it's cloud performance engineering. And everything is on the cloud side. So that is why. Okay. So let's introduce the course. So on the cloud computing part, we have a lot of cloud service providers, but we're going to cover AWS. Okay. We have Azure and GCP as well. But to learn all the cloud service providers is, if you know one, it's very easy to relate others and learn. Okay, but we're going to start with AWS. I have observed that people are not very much comfortable with Linux command. If I just ask, like, in Windows, if I ask you, like most of you, I'm not pinpointing anyone. If I ask how do you zip a file, you know, right click zip. But if I ask the same thing, how do you do in Linux? People struggle, right? Or about the operations, a lot of different operations that we have in Linux, like finding a text in a file. You know, in Windows, you know, Control F, you do it, right? But how to do the same thing in Linux? Because when we are in the current world, is whatever things that we have discussed, microservices, Docker, and containers, is mostly we are working on Linux operating system, right? So we need to be very much comfortable with Linux, how we are with Windows. So the second topic that we're going to discuss is about the Linux command line to get you comfortable with Linux. The tagline is you will be as comfortable with Linux as you are with Windows, right? So that's part. Then we'll talk about the software application architectures. What is microservices? What is monolith application? What are the differences? Why we're talking about microservices? We'll understand about that in detail. Microservices, and then we'll talk about container engine, Docker. How do we create containers? And where do we host these microservices? So once we create the containers, we can host the microservices. So this is where. So we're going to talk about Docker here. And on the orchestration part, we're going to talk about Kubernetes. We're going to talk everything. Every topic is being covered from scratch. Like I assume that my audience doesn't have any clue about these things. So that's how I have been taking up these topics. Then we'll talk about how performance engineering fits in DevOps, right? And then continuous performance testing in CI/CD pipeline, because since as part of DevOps, the main thing is to create CI/CD pipeline, and as a performance testers, we can also contribute to that CI/CD pipeline by our performance testing job, right? Job means a series of tasks, one of the tasks as part of the CI/CD pipeline. So this is what we're gonna cover in the course, right? Any questions on this? Okay, we're gonna go in detail what all we're gonna cover. Okay, so on the cloud front, we're gonna cover everything. Okay, from scratch. Um, we'll understand what is cloud first of all, why we're talking about cloud, how it is different from your on-premise, right? And how you will everything is hands-on. Everyone would be able to get the AWS account created, and everyone would be practicing here in the AWS account. We'll set up the budget so that you don't exceed the budget. We'll talk about different things. I'm not going to go in detail because if things are new to it may be overwhelming. But trust me, after this course is done, you will think, okay, this was a simple thing that I have listed, not a complicated thing. For a few of you, those who have not worked simply, these things may look gibberish or something, but it's simple, quite simple. You do have to know this if you are learning cloud, right? We'll talk about cloud from very scratch. We have a monitoring as well. The out of the box, we have AWS CloudWatch. From the monitoring front, we'll talk about that. AWS CloudWatch, right? And then we'll talk about the Linux operating system, right? I have just listed few commands, right? You know how to download a file in Windows, but can you directly download a file or a tar file from Linux? What command you use, right? We use wget command or curl command, right? So the simple things, right? So we're going to talk about these things. We're going to show you. I'm going to create a VM in AWS and I'm going to execute these commands. Right? That's how it will be. You'll be as comfortable with Linux as you are with Windows. So that is the tagline, right? I believe in. So we're going to discuss this. This is going to be the second topic that we're going to discuss. After that, we're going to talk about like soft application architectures. What is microservices? What is monolith application? What is differences? Why we're talking about microservices? How it is different than monolith application, right? We'll talk about that. And then we'll talk about where do we host these microservices. Once we understand where do we host these microservices, that will bring our new topic. Next topic is container engine, because we need to create containers to host these microservices. We'll understand how do we create containers. I just mentioned, I was explaining about that, how do we create containers, but we'll actually see here that how do we create containers. We'll use Docker. We'll install a container engine called Docker on our VM, and then we'll create containers. We'll see that how do we create that. We'll understand what is Docker volumes, Docker network, how these containers communicate with each other, how can you spin up multiple containers at one shot. Let's say app server, web server, database server, all these containers in one go, in one VM. How can you do that? We'll use Docker Compose to that, right? Okay, it is simple, guys. If you have not heard, things may be overwhelming, but trust me, it is as a very simple thing. If you know it's simple, if you do not know, it becomes difficult, right? But trust me, it's simple. We're going to talk about that. After that, we're going to talk about container orchestration engine, because once we have a lot of containers, how do we manage this? How do we auto scale? How do we auto schedule? How do we load balance? What is Kubernetes architecture? We'll talk about that. What is HPA, horizontal pod autoscaler? What is cluster autoscaler? We'll talk about these things in Kubernetes. Right, everything we're going to talk about, and we're going to talk about EKS. That is about one of the AWS services that we have in Kubernetes. EKS, Elastic Kubernetes Service. We're going to talk about that. So what we're going to do, the plan is simple. Everyone would be creating an account in AWS. Everyone, like this account, like how am I login? Everyone would be having this account just after a few days of our sessions, right? And we're gonna practice everything. So everything is hands-on, but yeah, you need to understand the theory, obviously, right? And everyone will have this account created, right? So that's how it will be. So let me just log in and show you. I hope everyone has. I'm just assuming, so everyone just log in. So this is how we're gonna log in and we're gonna practice things. We're gonna create our own VM virtual machine because they have already done the virtualization. AWS has installed the virtualization software on a physical server, and we'll understand which service to use to create a VM. So we're gonna use EC2, right? Elastic Compute Cloud, EC2 stands for, and then we'll create VM virtual machine, our own VM. We'll practice things there. So that's how everything is going to be hands-on. We're going to create our own instances, right? We'll understand what is Elastic, everything we're going to talk about. So from very scratch. So that's the thing. Okay, so let me just continue. Okay, then after this Kubernetes, we're going to talk about DevOps, where performance engineering fits in DevOps. And what is DevOps? First of all, we'll understand, and then how performance engineering fits in DevOps. What are different life cycles, DevOps life cycle that we have? We're going to talk about that. We can be engaged directly in the planning phase as a performance engineers, and obviously in the performance testing phase, and obviously in the production monitoring phase as well. Right? So we'll understand things here, and we're going to talk about continuous performance testing in DevOps. We're going to schedule our CI/CD pipeline, and we're going to create such a job, Jmeter job. This is the live screenshot which I have taken from one of the sessions. We're going to create this Jmeter job, and we're going to create this CI/CD pipeline. GitHub. We'll talk about GitHub. We'll talk about Docker Hub. We'll talk about Jenkins, right? We'll talk about we'll create a EC2 instance. We'll install Jenkins. We'll install Java. We'll install Jenkins. We'll talk about different DevOps tools. We'll create CI/CD pipeline. So that's how this course is planned. Okay. So yeah, this is what you will learn by the end of this course. Right. The main point, everything is from scratch. That's the main point, right? And yeah, you'll be learning a lot of things here. So I hope you would have figured out by this time, right? So yeah. Any questions if you have, guys?
So just wanted to know, as performance engineering topics when we cover and when we do this testing and integration with Jenkins and all, are we going to discuss about the key monitoring factors that could give us an insight into the bottlenecks?
See, when you say key performance indicators, see, I'm assuming that this course assumes that you have a good understanding of performance testing concepts. Okay, I'm not going to talk about Jmeter. The key performance indicators would be the same. I can tell you right now also. For anything that you have, one is that the when let's say you have any application, for any application, what you capture the business metrics, and then you capture the resource metric, the infrastructure, the CPU, memory, disk, network IO, disk IO. That's what you capture, and then you have a business metric. So I'm assuming that you, as a performance tester, you are doing that, right? I'm assuming that part. I'm not going to talk about JMeter concepts here or a performance engineering, Java performance engineering. I'm not going to talk about how to take a thread dump or heat dump, how do we analyze that, right? Those, I'm talking about the cloud from a cloud point of view, right? From a Docker, DevOps, from a Kubernetes point of view. This course is designed for that, right?
Okay. So are we going to talk about that? Maybe I'm not sure about the different settings in the cloud which optimizes performance.
Absolutely, absolutely. We're going to talk about those things. We're going to understand which VM to take and how do we optimize things. So that this course is based on that. That's what this course will talk about. You're going to be comfortable working in cloud because everyone is deploying their solution in cloud. So if you're comfortable in cloud, we're going to talk about networking. How not just performance optimization, security also is very important, right? So the application has to be secure also. We'll talk about from the security point of view also on the cloud, right? Because for the cloud, both are important. So yes, and obviously, see, the only performance part apart from the infrastructure, the application has to perform better. If the code is written needs some optimization, you cannot expect a good performance, right? You need to do some kind of analysis, code review, or thread dump, heat dump analysis to find where is the bottleneck. That could be the problem, right? But on the infrastructure part, we're going to optimize things.
Okay, yeah, sure. Thank you.
Sure. Right. So, and this is the link. Okay. If you really need some good information about the course, I'm going to paste this link to the chat option. Okay. Please go over that link. Right. Today was a demo of one session. So this is what I'm talking about. And for any further discussion, you can contact Mr. Kumar. He is the person, the Kumar. His contact number would be mentioned in the down below. Anyway, you will get to know the details as well in the. This is his contact detail. You can call him for the registration. For over any questions, you can I can ask my contact detail as well. Anyway, I'm in the WhatsApp group as well. So this is the course, and you have few demos also. You can from the last batch. Feel free to go over these demo videos, how what things have been planned, right? The first demo would be the same what we are doing right now, right? And you can go over the second demo as well. Anyway, and you can also attend the second demo on 9th June. Today is 7th, right? So we're gonna not meet tomorrow. You can go over these things tomorrow, and we're gonna meet day after tomorrow, and that's the day one. So we're gonna have some demos, free demos, maybe one or two demos. We're gonna have free demos. After that, we're gonna not have the free demos, right? So you can have feel free to attend those demos too. And I'm gonna directly start with the content, day one content here on 9th June. You can definitely connect, right? At the same time, right? So this is what I wanted to cover, guys. Do you have any questions on this? Do let me know.
What is the total duration?
Okay,
Question?
yes, this course is quite exhaustive course, okay, because covering a lot of things. So it takes around 40 to 45 hours. and we're gonna meet every day, weekdays, 9 p.m. to 10 p.m. Indian Standard Time, IST. So it takes about 2 months, okay, because 5 days a week, so 20 days a month, right? So 20 hours a month. So it takes around 2 months. But exhaustive course, a lot of things to be discussed, right? So yeah, that's the time.
Hi, Roshan. This is Suresh. One query here.
Yeah, hi Suresh. Yeah, tell me.
So, you just said that you're going to explain about how to optimize the cloud performance, right?
Hmm.
And so, is there any thing like I'm not sure whether this is relevant. So, is it covering the application performance optimization or the cloud infrastructure performance
Exactly. So
optimization?
I think I was very clear. When you say application performance, right? So those application point code review, application code, specific code review, understanding where is the bottleneck, uh, taking the thread dump or looking into the GC log analysis, trying out various different GC algorithm, and those comes under the application performance engineering, right? So I'm not covering that part. I'm looking at the cloud from the infrastructure point of view, cloud, Docker, Kubernetes, Linux. I'm mostly on the infrastructure point of view, focusing on that.
Okay, got it. Thank you.
Hi, Roshan.
Yeah, hi.
Yeah. So my question is, for application performance, as we are saying, you are saying it can be on the application side, like having some coding defects or something like that. But here we are doing as a infrastructure in cloud performance, right?
That's right.
Yeah. So like first thing we should have to like recognize like where is the actual bottleneck, right? Whether it is in infrastructure or it is in a code level or it
Exactly.
is in.
Yes, absolutely. As a performance engineer, that's our job, first job. Yes. To troubleshoot, to
So
narrow down the issue. Yes.
so we are here we are assuming like we have a, application hosted in cloud and we are going to optimize that application performance
First,
using these different techniques, right?
first of all, we're gonna understand how things are done. First of all, we'll understand how things are done in cloud. What are different aspects that we need to consider if you're working in the cloud, right? If I tell you there is something called security group, which talks about the port restriction of the port and having the right number of access, right people. So you need to understand what is the security group first, and then I'll talk about how do we configure it, what it makes sense. Then I'll talk about networking, right? How networking works in cloud, right? So those point of view, from the everything is from the infrastructure point of view, I'm going to cover, and that itself is taking this much time. Yes.
Okay, so like my question is, by end of this course, like how I can recommend, like for any infrastructure level improvements or like that.
See, as I mentioned, right? So, okay, so I'm not sure what is your like understanding of cloud nowadays. First of all, I don't know much about your understanding of cloud. So, just to generalize this answer, see, if you know how things are done in cloud, if you know how things work in how things are deployed in Docker using Docker containers, how things are deployed using Kubernetes, right? If you know that part, that is going to solve a lot of infrastructure problem, because you can understand that this is not the problem, right?
Okay.
You can understand from that point of view. So I'm going to basically tell you how things are being done, and you will understand that okay, these are all things that you need to consider as part of infrastructure performance engineering, cloud performance engineering. That would be your takeaway from this. How things are being done, how things are getting deployed in cloud, how things are being deployed in containers. What is containers? How things are getting deployed in Kubernetes? What is Kubernetes? What is auto scaling? We're going to talk about auto
Yeah.
scaling in the cloud. You have. I'm going to talk about. I think I just missed to highlight that part. we're going to talk about very important thing, load balancing and auto scaling. How automatically things, see, you are not going to sit in front of your system and see, okay, you have a 500 user load, so you just need 10 VMs. What if 700 user load came? Will you be doing it manually, setting up users, setting up additional, provisioning additional VMs? Or you want
No.
automatically things to be done, right? So we're going to understand
Yeah.
how do we do things in cloud. We can understand that part. How do we set up, how do we do auto scaling, how do we do load balancing in cloud? What are different services that you have? Let's say in the cloud, if the things have been deployed using S3 or EC2 or EBS, EFS, let's say these are the part of your architectures. If you understand, then only you can troubleshoot, right?
Okay.
If you do not understand what is the use of S3, and if you see that in your architecture, application architecture, you see S3, EBS, EFS, Lambda are being used, API gateway are being used, this particular VPC are being used, you would not have any clue about the architecture.
Hmm. Okay.
So to get the understanding, you should know this.
Yeah, hi, are they speaking?
Yeah, hi. Hi.
Yeah, my question is, will you cover how infrastructure is tested in this course?
Can you repeat your question?
My question is, will you cover how we can test infrastructure? Because you said we have to know the performance of the infrastructure. So how can we determine
The
infrastructure?
I think I got your question. The infrastructure testing we are not doing. We are going to monitor the infrastructure. Infrastructure you will be giving load to the infrastructure by the normal load, right? And you're going to monitor the infrastructure.
Okay.
Roshan. Roshan?
Yes, I'm there.
Thank you. I mean, by opting this particular course, which is Cloud Performance Engineering in DevOps, what are the job opportunities we can expect in market for a fresher?
See,
I mean,
as a fresher,
usually the market will be looking for AWS cloud practitioner or kind of architect engineer. Especially, I mean, they are specified specialization they require. But when we go through this particular course which you are offering right now, that is Cloud Performance Engineering, what will be the job opportunities?
okay, so but first of all, this course was basically designed for the performance testers or engineers who have to transition to this technology. But if you are a fresher, right? So I can just tell you, you if you are looking for, yeah, there are multiple options here. Okay, so you're gonna have AWS here, you're gonna have Linux here, you're gonna have Docker, you're gonna have Kubernetes here. So you can definitely out for cloud support engineer.
Okay, so the cloud part which you're you're going to cover in this in this training session, is that enough, much enough, or more enough to get into, to have a brief knowledge which is
Absolutely.
equivalent to a cloud practitioner?
Exactly, cloud practitioner. I'm gonna give you in-depth knowledge on the solution architect as well. So cloud
Okay.
practitioner talks about mostly what is AWS is all about, right? The name in the what this particular service is all about. I'm gonna give you in-depth knowledge of a solution architect as well, because I'm gonna talk about this particular course designed for the performance testers who need in-depth knowledge of the architecture as well. So I'm gonna talk about that as well.
And do we have coding part as well included in this?
Not much. Not coding is not required. Only for the infrastructure provisioning or infrastructure. That is truly DevOps part. If I include coding, that will be DevOps part. So no, coding is not there.
Okay. Okay. So you are not including DevOps as in this course.
Only what a performance tester is required to know. I have covered that part.
Okay. Okay. So that whatever a performance test requires to know, is that insufficient
Yes,
to be in the market?
more than sufficient.
Okay. And will you be giving some live projects to be working on that?
You're gonna just practice what we're gonna go through. That is gonna be your assignment daily.
Okay. Thank you. Thank you, sir.
Sure.
Sorry, you said you are not going to cover a coding part in this course. Then how do we? Hello?
Coding part, when I say coding part, you need to understand what coding part. On the self-scripting, I'm gonna talk coding part. That is the scripting part, right? Coding part,
Okay, scripting part.
scripting
It will
part
be covered, is that
will be
right?
covered, yes.
Okay. Using the Docker
Yes.
compose, okay.
Docker command, that's most like commands and scripting, right? So coding part, when I say, I'm talking about from a developer point of view. So no, we are
All
not covering
right.
from a developer point of view.
All right. Okay, thank you.
Sure. Okay. Any more questions I can answer? Anyone? Before we wind up. These are the feedbacks of my students, guys. So those who have enrolled already. So please go over this link. I hope everyone has got the link. And feel free to attend demos, okay? Feel free, okay? No worries about that. So you can, you have demos coming up starting from Thursday, that is 9th June. So we'll be meeting on 9th June, right? So around 9 p.m. IST. Two demos would be absolutely, everyone would be invited to such two demos. So feel free to attend and ask any question if you have for the follow-up questions.
Oh, okay. So day 1 and day 2 are again demo sessions?
Not demo, I'm going to cover exactly start the topics. But demos, when I say, it's going to be for everyone.
Okay, but the regular class starts from 13th.
No. Regular class starts from 9th.
Okay, yeah.
I'm not going to re-talk the same thing again on take. Yeah, so I'm going to continue. Okay, I think we are all good. Okay, guys, if you don't have any question, we can mind. So thank you everyone for joining this demo session, and feel free to ask any question in the WhatsApp group, and feel free to reach out to Mr. Kumar for any follow-up question, right? And feel free to go over this detailed syllabus that I have not gone through. I have not talked about each and every topic. If you're really interested, please go through the topics separately, what I'm covering in each of the topics. And feel free to contact Mr. Kumar. Okay. So thank you very much, guys. And I will see you on Thursday, 9th, right? So thank you.
Yeah,
everyone.
sure. Thank you.
Thank you.
Thank you, Roshan.
Sure.